Cool, I get the nod back. So Douglas Fallstrom, I run the products team. I'm here to tell you a bit more about the product. First, I'm going to start by giving you a little bit of the basics because there are some new faces in the room. Make sure you don't miss out on the cool stuff we'll talk about after that. And then we'll end the session today after we talk about some verticals with a demo, live demo, done remotely. So first, about the product. DataSphere Metadata Engine, you heard the term. What does it really mean for you as a storage person? What does it mean when you just collect metadata? So for us, it's a lot more than POSIX metadata. Just to start that right now, we collect a lot more information than just M times and A times, and when things are modified. We collect performance telemetry, we collect when things are last open, and we're going to be collecting even more and expose them to the end user as richer attributes goes on. And the beauty of our metadata engine is it's completely storage and vendor agnostic. Whether you're using, honestly, NAS or object or even block in several cases, we're able to collect and use that storage in the same similar global namespace. We're able to virtualize the view of your data in that together within metadata engine. So by taking all the metadata, we're able to give you a namespace that is separate from the physical storage. And that's really the big power behind the metadata engine is to separate these two pieces, to separate the physical location where data is and where you think it is, where it is in your namespace, whether it's in a subdirectory, whether it's a directory. When you have that power and you apply that power across any one of your storage vendors, across several different storage topologies, you can do a lot of things with the data. Most importantly, what we spent a lot of time on initially is automating the flow of the data. And I'll talk about that specifically, how that works today in certain areas. That's really something that, one touches data migration. It touches, storage migration, if you want to think of it that way. It touches data tiering. It touches, migration into the cloud. Once you automate the flow of data as a day-to-day task, a lot of day-to-day tasks as admins generally end up doing, they're just gone. They're just automated. And they can spend time figuring out, okay, instead of just always moving this directory, what else can I be doing with the data I already have? What more can I offer my services to my end users? So we will look at this as we're helping make the storage a lot more efficient in several ways. One, you can utilize storage at a much higher utilization level without risking running out of space. Because suddenly when you start moving cold data away from your old flash tier, your old flash tier can run at 80–90%, assuming you can deal with the peak workloads without risking running out of space. The same thing if you look at your mid-tier and so forth. So it introduces a fair amount of flexibility for a storage person to deal with how to do the day-to-day management. And if you have questions, feel free, obviously, to halt me at any point, otherwise I'm going to power on. You'll hear me say these two terms quite a bit today, DataSphere and DSX. DataSphere is the metadata engine. That's our product we sell. That's what everybody will be deploying minimally. It has several internal components that allows you to run the UI in there. It allows you to run the analytics in there. It's always sold in HA mode. So you can run it in a single node mode. In the demo, I'm doing that. In production environments, you're never going to run anything obviously in single node mode. And we'll talk about what we've done from a resiliency perspective as we go through the deck, because that is something that comes up with customers. If you think of us, we're collecting the metadata for potentially tens or hundreds of filers that sits underneath us, and we're aggregating that up into a unified global namespace. If that DNS for data goes away, then you're in big trouble. So you want to make sure it's well protected, that it's well managed, and if something, God forbid, goes wrong, you can recover as quickly as you possibly can to meet your own service levels. And we've implemented several technologies to do that. We're a software-only product. You can run bare metal or virtual. It's completely up to the end user to pick. We have no preference other than both are easy to install and use. The DSX is the workhorse of the family. That's where all the actual work is. So DataSphere only touches the metadata. It never ever touches data. Right? So that's something that's completely segregated between the products. DSX is the one that will touch the data. It will be in a data path when it moves files, and we'll talk about that. It will be in a data path when you move things into the cloud, when you want to move things up and back. It's a very pluggable and scalable architecture. For example, our cloud connector, we have an S3 connector today that will be scaled out to additional vendors and protocols in the future. The DSX itself is a scale-out architecture. So you look at this and you can say, how many do I need? Well, it depends what you're trying to do. Do you have 2,000, 10,000 SMB clients? Maybe you need a couple of them. Are they all super heavy IO users? Maybe you need a little more than just a couple of them. The cool thing here is that you can spin them up and you can make them go away. They're completely stateless. So if you have, let's say, a peak operating environment where you need, let's say, 10 during the day and only need 2 during the night, you can absolutely do that. Everything will just rebalance automatically, and DataSphere will just manage the intricacies of that. We have the portal, and that's our legacy access. And I'll show you this in a diagram how it all ties together. Portal allows the legacy clients to go in there. So, I mean, we're not just an NFS v4 company. We allow, obviously, legacy protocols, and we offer the same feature set and functionality across all the protocols we support. And that's what I'll talk about how we do it. Before we get to the how, a little bit of a recap, because it's been a while since I've been up in front of you guys and told you what we've done. We've done several releases since then. We just released 1.3. We're about to show you 2.0 today as an early access. So 1.2 recap was back in March. We did a press release. We did many briefings and articles on it. The focus of the 1.2 release was to bring it into more of a production deployment. We were engaged in a lot of test and dev engagements. Generally, when you start a product, that's where you start with big enterprise customers. They're not going to put you in your production data center from day one. So test and dev was where we started. We moved that into GA. We moved it into production. Some of that was make sure we built up the reliability of the back-end product, things like clustering, backup and restore of the metadata and so forth into the product at that point. We added some key functionality in it, and we'll go through it on the slides. We also added the ability of doing phone home support. So, it's not all about when things are great. When things are great and no one calls you, that's fantastic. In reality, people will call you, especially when they're in an important spot in a data center. So we have phone home, and we have automatic heartbeats going back to us. So we know when things go wrong right away. Excuse me. So NFS v4 is something that we work on as parallel to the product. We have several staff, engineers on staff to manage and help propel the NFS v4 standard forward. It's now been completely ratified and supported in 9 distributions. We also did a separate press release on this, available in Red Hat 7.3 and later, and generally NFS, Linux kernels 4.9 and later is the ones we support with full feature functionality set. The native clients is something that's important to us. We don't want to force clients to deploy their own software to use our storage metadata engine. It doesn't make a whole lot of sense. So we took an open standards approach when we developed the product. Everything is parallel. We have a scalable backend from an NFS perspective. Flex files are the way we're able to do live migration of data, and we'll talk about that quite a bit. And I should say, RHEL 7.4 has additional enhancements coming. You don't need that to deploy our product at all. It's just simply something that makes it maybe a little bit faster, more bug fix and so forth. We work very closely with Red Hat and a few other vendors to make sure that everything we work on gets pushed upstream and then falls back into the distros. Excuse me. All right. So,
what's the state of play for SMB? Because last time
fully supported. I'll talk about that specifically. I have a slide on that. Absolutely. So we support SMB 2, 1, and 3x, and a bunch of other stuff that I'll talk about on the slide.
Okay.
Yeah, absolutely. 1.2, we said we do 1.5 billion objects. What's funny with the number is that architecturally, most companies never architect a limit in there unless it makes sense to have a limit. We're limitless as far as that perspective. We tell customers exactly how far we test things, and that's what we support. At the time we tested 1.5, it takes a lot of time to create a lot of files. I'll show you in the next slide, we're now at 1.67 billion files, and we'll continue to grow this over time. And, a few months have passed, and the files keep growing. We have systems that we do longevity testing on, and they just keep at it. It's important for us.
Is a file or a block one?
An object is a file or a directory, a symlink or hardlink, for example. Most of these are 80% to so files, and everything else is, you have a mix of things to mimic a real environment. The backend is generally NAS for these environments, for this particular test setup. We talked about the metadata production. I have a slide on this I'll speak about specifically. We started doing the offload of snapshots and clones. So once you manage a namespace, then it's really difficult to rely on the underlying storage to manage their own namespace, so to say. So that really breaks fully if you do snapshots. So since we can move files around between different storage systems, if you did a snapshot only on one of them, clearly you're not going to be snapshotting it when it's on the other storage system. So snapshots are coordinated intentionally by us inside the metadata engine. So we'll speak about that a bit. But what's important is that we leverage the underlying storage functionality to do the actual data mobility, data movement. So we call into this native storage APIs. We do storage cloning underneath the hood when you're doing a snapshot if needed. So that way we have a scalable infrastructure that works across many systems. So you don't sit and just suddenly you get bottlenecked when you do a snapshot and you can't do IO for a while. They're relatively quick. And if there's a data copy operation, it happens within the storage device itself using whatever optimized process that Array has already figured out how to do. Right? So we're not reinventing the wheel. We're just leveraging what already is existing.
Do you have a preferred hardware platform to interact
Not really.
with?
I mean, we support any x86 hardware we run on. All the major players are something we validated in our labs. From the back-end storage systems, we validated NetApp and EMC Isilon. We also support NFS Other, which is anything else.
Obviously, you're not going to get some of those more elegant functionalities if the customer's got a simple NFS JBOD sitting behind it. Yeah.
The challenge is when you have something that can't do file cloning, what happens when you have snapshots? And today we don't support snapshots in that device in the back end. So what we do then, don't place data on that device that needs file cloning. Data placement and data movement is something we do quite well. So we can dictate that, say if your data needs snapshots, move it off a device that doesn't do file cloning. So there's a way out of that. We haven't run into that yet, because most customers, they're all enterprise customers we're engaging with, and they're all pretty much brand name storage at this point. But we run into the most in our own labs when we play around with things that are not yet out there. So this is an eye test, so find the number where the files are. So jokingly aside, this is a screenshot I just took the other day. Updated it, 1.67 billion files. We run the system, and it's a live system. It's doing data mobility. Things are moving. There's I/O going on. I mean, it's not like it's an idle system you just kind of create files on. We do upgrades on it. It generally stays about one release behind to mimic what a real customer would do, because they don't always run the latest, as much as that would be cool. So the UI you'll see today is different from this, because it's the new UI. This is the old new UI. And come forward maybe about a month or two, we'll upgrade it to the 2.0. So it's just the way we run a system to try to mimic a real production environment.
How many DSXs are running this?
This one is, I think, only 2 or 3. It's very small. That's why the capacity you see is tiny. It's only about not even 2 terabytes. That's our biggest concern. Now we need to figure out how to get more storage on there. We can clearly add storage to the system. It's more about how the lab infrastructure is managed. It's an internal problem. One of the benefits when you offload the namespace and separate it in the allocation of data from where it's presented is that adding storage to a global namespace for us is completely no risk and no non-disruptive operation from an end user. You add storage in there, it's not being used unless you tell the system to use it. So it's very different from, let's say, a storage array where you say, I'm going to reformat my file system or my LUN, I'm going to add another tray of disks. They're going to have to do a bunch of data movements and rebalance RAID layouts and so forth. None of that happens in our system. So adding storage is very trivial. This happens to be a lab challenge for us.
So
Yeah.
it says that the bandwidth there was 22 megabytes a second. Is that what I'm seeing for writes?
Yeah.
And about 75 megabytes a second for reads?
Yeah. I can't tell you what other workloads are running at the same time. So I can tell you what the number comes from though. And I'll show you this in a demo. This is user-only bandwidth. So this is the telemetry we're capturing from all the clients coming back. We're not showing the back-end storage bandwidth. That might be different. Right? So we're doing mobility between systems. We're capturing that, we're not showing it. So what we're getting is a telemetry back from all the clients. We know exactly how much they're sending every 15 seconds. And we're displaying that in our product. And we're aggregating that up.
I'm sorry, is this some metadata bandwidth? Is that what you're
No, the I/O bandwidth from the client. So from the client, and I'll have a slide on this, so I'll go through it in detail. But on the clients, every 15 seconds, we get a telemetry data dump. And that accumulates, that's the summary of all the 15 seconds of I/O that happened on that client.
I got you.
And then that's just added up here in the dashboard. Yeah.
So you mentioned if you're adding capacity, it's non-disruptive, it's transparent, but you're not rebalancing any data across any of those physical.
Not unless you want to.
Right. Okay. Because otherwise you might generate hotspots.
So automatically our system will balance across everything. What we're seeing customers do is they want to use these set of systems for these workloads. Or they want to say, I want to put my hot data on my all-flash system. And if you're adding a capacity system, it's not going to match the attributes. It's simply not going to use it until you move capacity-style data in there. So the reason I mention that is it's completely up to you as an end user to figure that out. And when we engage with one of our larger customers, they're a service provider, they love the fact that they can add storage in there and let the storage cook in their test environment, even though it's in a production environment where no one is using it. And they can create their own share and hammer at it and make sure it's all the way they want it. And then they add it into the objectives to use it in the real production data. It fits their workflow extremely well, and for them, it lowered their risk to add storage in there, because if something went wrong when they're doing their testing in their production environment, it wouldn't impact any actual application data. So it completely depends on how you like to add it in and what your objectives say. So the answer is yes and yes, and depends, right? The other piece we added in here was, and I spoke about it a bit, the reliability for our metadata engine to deal with recovery. I should say we also pushed over 200 fixes back into the open source NFS v3 and v4 clients to deal with reliability better and performance and a few other things. So it's not always in one end of the spectrum you fix things. You also find things, and you know what, this is better fixed in a client rather than hacking the server. So we work across that board. All those have been accepted in upstream in 7.3 and later. We talked about the cloning. I'm not going to show you this today because it's a script we run, and the environment I'm demoing doesn't have all that data in it. But we have a ability of doing on the command line, showing you the files that are generating most amount of I/O to, as well as the clients that are generating that I/O. And you can filter these. I just won't be able to show you that today. That's a really cool one. We developed that for the media entertainment market. When they're doing rendering, for them it's really important to see what files are really hot in my system and which client is the one that's generating the most amount of I/O. And then they can log into that client and figure out, is it really, did my code do something that it wasn't supposed to do? And so that's important. The other piece, this is brand new, super exciting for us. We have essentially two versions of DataSphere. DataSphere started in enterprise. We went after the large environments, so that's where we developed all the functionality and resiliency for it. We then got feedback from customers that they want to use it in more places than one. So we just developed a new version called DataSphere for lines of business. It's best suited for smaller environments. It goes after, let's say, a small site where you have maybe 1 or 2 arrays and you want to move into the cloud or use the cloud as a tiering. You don't need necessarily all the massively spanning global namespace functionality. It's not relevant because you simply don't have enough capacity in that array or that site to manage. But you want to simplify management. You don't want to have to deal with necessarily snapshot backup. So if you have a centralized object store, for example, we can take snapshots and move the actual snapshot data back into the object store. And we'll talk about that quite a bit today because that's also new functionality in our product. So that allows you to have a remote site where you don't buy more storage for it. That's the way we looked at it. That's the feedback we got from the customers. Like, hey, I want to have a site. I don't want to buy more on-premise capacity for it. I just want to use the cloud for the old data, and I don't want to change anything from an application perspective. That's something that we do completely from a product perspective. If someone wants to move from one to the other, it's a license-only upgrade. There's no code change. There's no change from a storage config perspective. It's a very, very simple transaction.
Scale-out namespace? For a line of business, there is no scale-out namespace, but for
there is.
enterprise?
There is. It's just mostly the focus of the product is you're not going to see, let's say, 10s or 20 arrays in a smaller site.
So it's a limited number of storage arrays.
Correct.
And also, heterogeneous storage is only supported in enterprise level?
It's supported on both. What we've seen with customers is that they have one brand on the remote side because they don't want to deal with more than one brand. And we support multiple ones as well. It's just we don't necessarily see it from an ask perspective. But you can definitely put, let's say I'm going to pick on NetApp and an EMC on the line of business, and it'll work just fine. And you can pick any number of cloud destinations. And we'll talk about cloud quite a bit today on how we do the mobility into the cloud, how we bring it back in.
Is it license capacity based?
No, it's storage node based.
So physical storage nodes.
Yes. So unlimited capacity on either side. We don't really care whether you have a petabyte or 100 petabytes of data. It's more.
So would you consider an Isilon cluster with 144 nodes one storage unit?
144 nodes.
Oh. Even though it's a cluster scale-out storage.
It's not a storage system, though. So we have a couple of different components. We have storage system and storage nodes. This one happens to be limited on storage nodes. Because obviously it didn't really make for a good comparison.
Would that also, would a node be a controller in that instance? So if you had a quad controller system, that would be 4.
If it looks like 4 different storage nodes, then yes. So if I say NetApp failover pair, that would be 2 storage nodes. All right. So I think we're doing pretty good on time. the metadata engine, the core, other than obviously virtualizing where data is, and what we spent, I'm going to say 9 months getting right was the mobility of data. And I don't mean like we corrupted things along the way. It's been getting it right to the point where the application doesn't notice when something moved from A to B. It's very, very similar in concept from VMware's vMotion, from VMs back in the day. It took a long time for them to get it right. We spent a ton of time building this internally and running with customers. So I'm going to take you through how it works, because it may not be clear. And this works the same way whether you have NFS v4, v3, or SMB. I'm showing a v4 example, mostly because it makes the screen simpler to read. But the functionality is exactly the same. It just happens in different places. All right? So imagine you have an environment where metadata engine, you have an application running, something up there. Doesn't really matter what they run. It could be an ESX server we're running as a service VM. It could be a bare metal application, data path. So we segregate the metadata from the data, whether it's SMB or NFS v4. The only difference in an SMB and v3 case is that we have a DSX, we have a data portal in between. And then we'll talk about that in a bit on that. 2 storage systems for simplicity. When an application opens a file in NFS v4 land, it's very similar. It opens a file. The request is a metadata request. I'm opening this file. Give me a rights to read or write to it. The request goes to the DataSphere. It hands the layout out to the client, to the NFS client. That layout essentially says, you want this file, it sits over here on this storage target. Storage targets only speak NFS v3. They don't speak NFS v4. So any old NFS v3 will work just fine. And then the I/O starts. Right? So the clients will do read or write I/O. It doesn't matter. I say it's 100% right. They start doing I/O. We decide for some reason that we want to move the file from A to B. It could be automatically triggered because you now want the performance-based move. It could be triggered because you're sitting there in the UI, which I will show you later, moving from A to B. It doesn't really matter why. What happens in the background is that we're going to trigger that on data, so we're going to recall the layout. What happens when you recall the layout is that the pending write that's in the pipeline right then will be finished. We're going to recall the layout. Immediately when this happens, it's practically in parallel. The client will say, well, you can't recall my layout. I'm still writing to it. Give me a new layout. And because we know we're doing this, we're going to give the client a new layout. But the layout's not going to point down here anymore. The layout's going to point to a proxy, the DSX data mover. Okay? So now the data path during the move, let's say it's 100% right, goes through the DSX proxy to ensure that the data obviously is copied and also all the writes are reflected into the new location. Very, very straightforward from a concept perspective. A lot harder in reality. The mobility process will take as long as it takes. It's completely bandwidth and workload dependent. Generally we see much less than 20% impact on heavy workloads. I have yet to have a single customer complain about it because they just don't notice it. This is obviously only applicable to, let's say, open files. Cold files are different, open files. The key piece here is that the client and the application, the file, the fopen call, it never changes. It's still open from an application perspective. There's zero disruption. They have no idea that this thing is going from potentially a slow old hard drive NAS to an all-flash NAS. Right? And they just see that suddenly the IOs are going to happen a lot faster in that case. And then when mobility is done, we simply reverse the same process, recall the layout, it'll flush the pending write, and we'll do the finishing touches on that, and we'll give it access again. So you don't even see IO blips. If you do an IO stat to say a second ratio, if you have something more granular, go at it, you might see a tiny, tiny little thing, but you generally don't see anything at all. So it's quite impressive, and it works really, really well. Mobility always happens between NFS storage volumes. Mobility into the cloud is a little bit different. We'll talk about that. It works conceptually the same way, but you're not moving open files into the cloud. We're only moving cold data into the cloud. Any questions on how that worked?
You mentioned that storage units can only speak NFS version 3, is that what you said?
The backend only needs to speak NFS version 3.
Only needs to speak, but they could speak NFS version 4.
They could, but we wouldn't use it.
Oh, okay.
We only use NFS v3 calls to the backend. So the only NFS v4 traffic that happens in our environment is between metadata for the DataSphere and the client, or if you use v3 going through a proxy, and I'll show that in a slide or two, and then between these two.
So the only requirement on the client side is to talk to, in that case, my destination is the DataSphere metadata engine. That's what I'm connecting to.
Right.
And he's actually explaining, no, I'm not really going to give you the data. It's this guy over here.
Correct. So when you mount, let's say you have a V4 client,
Yeah.
you're mounting using the IP address of the DataSphere, even though your data is all spread potentially on one or hundreds of NFS files below. And obviously, DataSphere knows where the data is, because that's what it does. And it'll just say, this file belongs down here, and it'll do the back-end NFS mounting.
Is mobility at a file level or a file system level?
File level.
So in ESX, I'm moving, my granularity is the VMDK file,
Yes.
ultimately.
Yes.
Works a little like some of the early APIs for storage from VMware EMC, via. But anyway,
Yes.
how does it interact with that, though? What if
For VMware, so if you run us in a VMware environment, we're a vVault provider. So we won't be using any VMware tools to move things around. We'll move it the same way we did it just here,
won't?
except the vVault provider is DataSphere. The NFS storage endpoint is a local VM running on every node. I didn't bring the VMware diagram with me today. I apologize for that. But, and then that storage service node will talk to DataSphere and do all what I just explained. Will do exactly the same thing.
And DSX is a virtual machine, effectively?
can be?
If you run it in a VMware vVault use case, yes.
We deploy one per host, so
Yeah.
we'll do a local vVol lookup.
You don't have to, but that's probably what we would recommend.
Best practice.
It depends on your scale of your clusters, honestly.
And the theory being that since I see SMB next to it, I can do the same thing for Hyper-V.
Not yet.
Okay.
You could. We haven't tested it, and actually, I'll take it back. One of LCs runs it that way. It seems to work just fine. Officially not supported,
Fair enough.
but feel free to play with it. It works. It has to work. We'll get to Hyper-V when we feel like we're ready. There's a few more things we want to do with SMB protocol that we implemented. They're Hyper-V specific that we haven't done yet. So that's why we haven't focused on Hyper-V yet. But it's definitely on the roadmap to get done. Okay. We picked intentionally NFS v4 as the standards today from our client perspective. We don't want to deploy proprietary client. My message to any customer, I can go into your existing environment with your existing storage, and you can get the same functionality as if you did a brand new deployment. You don't have to modify anything. The only thing you ever have to do with us is an unmount and remount on a client. We don't go and hack the client and transpose ourselves into a network stream or anything like that. That's the one disruption with primary data you get. It's like one unmount and remount, and that's it. Nothing more ever again needs to be done from that client perspective, from our perspective.
Yeah, you support block storage as well as file, right?
Yes, so we do support, yeah, it's not in this diagram. It's probably, I'll show you in another diagram, about a slide or two. I have it. Yeah, so we have a DSX store functionality, so we can take white box storage and use it as part of our overall namespace. It's mostly used in VMware environments where the data tends to be protected anyway. But yeah, we have customers doing that as well.
As far as the actual data protection is concerned, it's really on behalf, it's at the storage level that's RAID level or mirroring, whatever they want to do.
And we detect what protection you have. So, and I can show you in a demo. When we discover the storage, we look at what type of storage it is. So because we have Isilon and NetApp integration, 7 mode and C mode and so forth, and we know what you're running underneath the hood, and we know what level of protection that storage is running at. Same thing when you do DSX. We can tell whether storage is, let's say, 2 nines, 3 nines, 4 nines, and so forth.
And the metadata is software only as well, so you're actually using storage someplace to store the metadata.
Yes, so the metadata, we recommend you on the DataSphere itself to use things like NVMe hardware, or if you're running bare metal, even in the VMware environment, to do pass-through devices. Because your metadata performance will be no faster than what you can transact on a metadata server. So if you're putting slow disks on that thing, you're going to look really slow. So what most customers have done is taken either NVMe drives or something like that, something relatively fast, and dedicated that for DataSphere.
How's the metadata protected?
It's mirrored locally and replicated to a second node. And I'll talk more about how we've done the next step of protection. So at any point, you have 4 copies of your metadata at any point. Failover goes faster than any I/O will time out.
And is DataSphere, it's effectively a VM as well, or it could be an appliance.
Could be
Depends is it high availability? Or?
Absolutely. So you always run 2 nodes in production. So that failover is less than 30 seconds. So it's faster than any I/O timeout unless you somehow change your defaults. So I/O is not disrupted. So what happens when you fail over is that during those 30 seconds, the only drawback of failover is you can't create new files for 30 seconds. But any existing I/O and existing files can be used just fine.
If the layout's the same, it's fine.
Yeah, because metadata is not available. It's being transitioned to the second node.
Yeah.
So what happens is you synchronously mirror things locally, and we synchronously replicate to the second node.
The challenge is if you're migrating files from one system to another, the directory structure is now spread across multiple physical storage units.
The backend, yes, but not from a user perspective. From a user perspective, your namespace remains intact. We've moved the data.
But the namespace really is at the metadata level now, right?
Right, absolutely. We provide you a namespace. That's the key piece of DataSphere. A full-on namespace with the same capability you would have from any, I'm going to call it the POSIX namespace, and more. Because we collect a lot more telemetry than you would from a traditional file system. And so when you mount it, you get your namespace.
But you're physically creating a namespace on the storage itself.
Yes.
It's a local namespace.
We are. So we're using, think of it as a honeycomb structure, an object structure, representing that's the way we look at it internally. It's an object structure that represents the actual file data. And the file data is not striped or anything like that. Each file is represented by one object in the back end. Right? So, there's no, I'm going to call it sub-file optimizations across storage nodes, anything like that at this point. And so what customers have, so what we can do, a few notes on placement. So placement is kind of maybe what you're hinting towards. We can ensure that the data in one share sits on one backend storage node if you wanted to. So for customers, we can go in existing clients, existing storage. We can also support their existing way of allocating storage. Because the existing way is generally saying this share belongs to this NetApp, for example, or this Isilon cluster. We can do exactly the same thing. You don't have to change a thing the way you do things from today. What you get as a benefit is still the data migration. When you want to do a storage migration, you just click a button and we move all the data to your new destination. And I'll demo how that works today as well. It's very, very simple. So you get a lot of benefits when you're ready to use the data virtualization, the abstraction of the namespace. But you can do things, and it's important when you go into an enterprise environment to not say, whoa, we have this great product, and now you change everything you do to this our way of doing it. It's not working well at scale. A few customers may adopt it, but generally people won't. So we say you don't have to change anything at all. You can work with comfortable processes you have today. You can do them exactly the same way. And then as you feel comfortable with things, you can move to maybe more automated, more optimized.
To that point then, to what extent do you take advantage of the data services provided by the underlying storage systems?
Mostly for cloning, right? So for our snapshot functionality. And I'll speak to that in a bit, but I mean, we use the underlying cloning functionality. That's the only real data service we use today. We don't support DR yet. We're very open with you guys always. And once we officially support DR, and there might be some more services who support underneath the hood that, if someone has existing replication, it makes sense maybe to reuse it. But until we productize that feature, I won't necessarily speak to how we're going to get it done.
You're good on time.
Okay, good. Keep me on track.
No, you're good.
So we spoke about this. We spoke about we don't want to modify the client. So we don't require you to install NFS version 4.2 at all whatsoever. You get benefits from doing it because you're going to get direct access to your underlying data. There's no indirection whatsoever, right? Client to storage is a direct point. But you don't have to. The other piece, because one, it's in RHEL 3 and 7.3 and later. So anybody deploying a new Red Hat or CentOS, or as I said, anybody with a kernel 4.9 or later, so later Ubuntu's or Arch Linux or whatever you might choose to use as your client, even my Mac can mount NFS 4. It may not get all the layout stats right, but it gets some of it right. This just points to the fact that separation of the namespace is how we achieve the ability of moving things around to any underlying storage. When we move things into the cloud, from your perspective, it's just there. Access to it is going to be slower unless your cloud is super fast and has super low latency. But other than that, it's just there. And I get this question all the time with customers. I figure I would throw it up here so you guys can see what it really looks like from a data path perspective. So I'll take you through this a little bit. Various clients. Do we support Unix NFS? Absolutely. It's just NFS v3. Didn't have room to put it up here, but it works out fine. It would fall into this category. So for any legacy protocol, like SMB 2, 3, NFS v3, we use the portal as our gateway into the DataSphere namespace, into our DataSphere. The portal, all it does is extract the metadata from the NFS v3 call, dump that into the DataSphere, and the data goes straight through. We don't touch the data. We don't cache it. We don't coalesce writes or anything like that. We might do some read caching. So if the same request comes in to read the same block later on, it'll just be in the buffer cache. That's pretty harmless. It only benefits you. But there's zero write caching. So this thing is, think of it as a pass-through node. Performance impact is relatively low. It completely depends on the workload. We've seen this thing do gigabytes per second in streaming throughput. We know it can perform really well. That's even as a VM.
What about latency?
Latency depends again on the workload. So it might have maybe 10, 20% if you do one latency I/O. But if you're running a workload, you might see nothing because your workload is distributed. Remember, this is a scale-out architecture. So you can have 1 or you can have 100. I would say maybe 10 or 20 is probably more realistic in what you're going to do. But there's no real limit to it. I don't know what we decide that is the right one. What we tell customers, if you want a super low latency environment, the only way to get that is to remove all layers between you and storage, right? And that's to use NFS v4. Unless you're going to start using caching, but that kind of defeats the whole purpose of the number of copies and the cost of you managing your data. We much rather say that if you need performance, there's high performance, transparently move it to an all-flash system that provides that kind of performance, or an NVMe system that has that latency that you desire, and we'll move it there when you need it. And when you don't need it, we'll move it away to something that's more affordable to where you want to store your data cost at. Right?
That speaks to your question. So is a DataSphere support all flash, for instance?
Absolutely.
Storage? Yeah.
Yeah, the underlying storage, we support anything the vendors I mentioned support, right? But even hard drives. I mean, it just happens to be a slower system for us. And when you add storage into our system, we benchmark it just to get a rough idea of what it does. That number is nearly thrown away, I'm going to say minutes later. As soon as we start using it, we do get telemetry back from the clients. And from that, we can model what the storage is capable of. And that's a much more accurate picture than doing a one-time benchmark at one point in time.
You mentioned telemetry from the clients a few times. How are you getting that data from the clients?
It's part of the NFS4 protocol. In fact, I have a whole slide on that too. Part of what I don't talk about today. But yeah, so we get it from the protocol. So from this, it's built into the protocol. So we've decided that we want to collect this every 15 seconds. We can change that at any point in time.
Okay.
That's negotiated at the time of a mount, for example, or a file open.
But even though it's not in the data path, the client will send back to the metadata source telemetry on what it's actually doing with the data.
It's really, really imperative, because otherwise you have no idea what the client is doing. Because you can't measure it clearly. We get the same thing here. So we know what clients are coming in here, and we get the same kind of telemetry for all the files over here. Right? Even though it's speaking NFS v3, we're leveraging the NFS v4 capability to get the same file to IO mapping. Right? So it's all, it's all transparent. So every 15 seconds, we dump that data into here. We'll see. Maybe if you have tens of thousands of clients, maybe we'll collect it less frequently. We'll see. So it doesn't really matter, because every IO is still accounted for in that period of time.
So policy-wise, you could actually decide for a customer to migrate the files to load balance performance or load balance capacity, and you're using this telemetry information to determine what the performance are available from the storage elements?
Absolutely. In fact, the telemetry is a very powerful tool, because let's say you have 2 clients, right? And the second client sees the same storage, but he's 4 network hops away from that storage, and he has another piece of storage only 1 hop away. And that might be much higher performance for him. So the right answer is not to create the share just sitting on the one backend file that you forced it to do today, but it's to create an namespace that says that's the most optimal location for this client, and that's the most optimal location for this client. Hoping they're not using the same data, because you might get some,
replication.
Unlikely they're going to use the same data, but they are. I mean, we have some guard against that as well. We're not going to ping pong movement. We're going to say, you know what, if you're going to move that fast, we're going to wait to move it and see what happens over time. So it's.
We're collecting telemetry from the clients. Can that also be used as an auditing tool?
It can. We don't expose it yet, but we have all the data exposed. You can, theoretically, you can use it as a.
I'm sitting there in the metadata path. I know everyone who looked at every file and a HIPAA complaint or whatever. It's who read this data.
We can absolutely tell you which client opened what file and what they did to.
What about like
from a read and write
security, LDAP, ACLs, and stuff like that?
We'll comment that, but yes, we support that too. That's new in 2.0. We introduced Windows, very basic Windows support in 1.2. We enhanced it a little bit in 1.3, and then in 2.0 we have full ACL support, full Active Directory support. We even do things like cross-domain mapping. I'll speak about that on the slide on what that all really means. So we added a lot of functionality to be what we think of as enterprise-worthy, enterprise integration points. So when we slide into an existing environment, I mean, keep in mind, we're coming into an environment where they might have used the NetApp for 10 years. And they've used to a lot of rich functionality from not from a storage perspective, but from an enterprise integration perspective. And so that we're doing exactly the same thing from that perspective, because we layer on top of all that. The Cloud Connector is a connector as part of DSX. So I picture all these different DSXs here. In my demo, I have one. You don't have to have 100. You can do 2 or 3. It's really sizable for your environment. They are multi-purpose roles, so they'll do different things. DataSphere will automatically detect how busy they are and load balance mobility requests, load balance the cloud mover across all these things. So it's you can have 3 DSXs moving different pieces of data up into the same cloud bucket, and there won't be any overlap because they all synchronize and speak. And the mobility piece is synchronized across the nodes.
How do they handle failure of one of those then?
So failure, as in, let's say
the DSX.
Yeah. So NFS IP failover for the NFS piece. Same thing for the SMB endpoints. Right. So we monitor then the nodes themselves, or they're not responsible, move the IP somewhere else. Other than that, there's some account mapping piece, the stateful that we keep track of, the synchronized across the nodes. It's non-performance sensitive, but we just keep track of that because it's easier that way. All that is handled automatically. So the customer, they deploy preferably a minimum of 2 of these if they want an HA configuration. We're seeing 2 to 4 being pretty common in relatively medium environments. And then they go in and just let them be. And you can go power one off, and it'll do the traditional NFS failover if they're using it for portal access into another one. If it's in the middle of a move, we'll just restart the move on another node. Right, so all that information is tracked by data. So saying, hey, this guy's moving this. Okay, he's not responding. He's suddenly dead on me. I'm going to restart the move somewhere else to ensure, and we have some protection in place that you're not going to do 2 things at the same time, right? In case it fell off the network, but it's still doing something in the back end. So we have fencing built into all these nodes to make sure that there's, I'm alive. I'm going to do something, right? So does that help answer the? Okay. That was the last slide I have for me.
Yeah, Cloudflare is going to create an object
Yes.
for a file, so an S3 object, effectively?
Yes. We chunk. So I'm going to speak to the cloud piece and in my next section. So I'm going to, if you don't mind just waiting, I have a whole slide on it
I'm good.
to outline how that works.